Quick chemistry, reaction mechanisms, let's go. Really key with reaction mechanisms is to know what we're looking at, and that is the movement of electron pairs shown by your curly arrows. Your curly arrows should always go from something that's electron-rich to something that's electron-poor, because we're always talking about donating electrons to something else, right? That leads us on to talking about nucleophiles and electrophiles. Well, that suffix "phile" means to be attracted to. So an electrophile is attracted to electrons or attracted to negative charges, whilst a nucleophile attracted to a nucleus, for example, which is positively charged. Meaning, electrophiles are electron pair acceptors, whilst nucleophiles are electron pair donors. In your A-level chemistry course, there are 4 main reaction mechanisms that you need to know. The first being electrophilic addition. This typically happens between an alkene and a hydrogen halide or a halogen, but what's happening is that an electrophile is going to be added across a carbon-to-carbon double bond. What will happen is the pi bond is going to break, donate an electron to the electrophile, you'll form an intermediate carbon cation before finally forming a haloalkane. Another one we need to know is electrophilic substitution, which happens specifically in benzene. The delocalized ring of pi bond electrons is way too stable for electrophilic addition to occur. So what will happen is your electrophile is going to replace a hydrogen that's attached to a carbon, forming a new molecule. Nucleophilic addition normally happens with carbonyl groups. And what's really going to happen is the nucleophile is going to attack a positively polarized carbon, and you're going to lose the double bond between the oxygen and the carbon. Typically, you're going to form a new alcohol group with this as well. Finally, we have nucleophilic substitution, in which one bond breaks and another bond replaces it. Typically, it's going to happen with haloalkanes and hydroxyl groups, or with vice versa, an alcohol and a halogen halide. And we've gone through 4 different examples, but the concepts remain the same. Addition reactions make bonds, substitution reactions replace them. Reaction mechanisms can be learned by literally just copying what's on the mark scheme for that specific reaction and then reproducing it in the exam based on the context. So that's been quick chemistry. Hope it makes sense now, and we'll catch you in the next one.